Our solar system is a vast and bustling neighborhood, a gravitationally bound family of celestial objects orbiting a single star, our Sun. It consists of the Sun itself, 8 planets, numerous dwarf planets like Pluto, moons, asteroids, comets, icy bodies. But this cosmic family is not static. It is in a state of perpetual, intricate motion. Understanding this movement is fundamental to understanding everything else. The dance of the planets dictates the length of our days, the passage of our years, and even the very climate that allows life to flourish on our own world. The story of the solar system is a story of motion, from the smallest spin to the grandest galactic journey. This constant movement is the invisible force that shapes the reality of every planet. Think about it. The simple act of a planet spinning on its axis gives rise to the fundamental rhythm of day and night, a cycle that governs the behavior of life itself. The much longer looping journey a planet takes around the Sun defines its year, charting the course of its seasons. These motions are not random. They are governed by the elegant and unyielding laws of physics, primarily the force of gravity. The Sun's immense gravitational pull acts like an anchor. Every major body in our solar system engages in 2 primary forms of motion. Rotation, a planet spinning on an invisible axis. This gives us days and nights. Earth, 1 rotation, approximately 24 hours. Jupiter, the speed demon, rotation in less than 10 hours. Venus spins very slowly and in the opposite direction. Result, a day on Venus is longer than its year. Revolution, the journey a planet takes around the Sun, called an orbit. Earth's revolution takes about 365 days, 1 year. The orbits aren't perfect circles, they're ellipses, with the Sun off-center. A planet's distance from the Sun sets the length of its journey. Mercury zips around in just 88 Earth days. Neptune takes about 165 Earth years per orbit. These 2 motions, rotation and revolution, happen at the same time. As you sit here, Earth spins at over 1,000 miles per hour at the equator, and it hurtles around the Sun at about 67,000 miles per hour. We don't feel this incredible speed, a testament to gravity and inertia. The tilt of a planet's axis is crucial. Earth's axis is tilted by about 23.5 degrees. It's the tilt, not distance, that causes seasons. Spring, summer, autumn, winter. This cosmic waltz applies not just to planets. Moons orbit their parent planets. Asteroids follow their own orbits. Comets trace elongated paths under the Sun's gravity. The whole system is a complex web of gravitational interactions. A clockwork universe. The motion doesn't stop with the planets orbiting the Sun. Our entire solar system is on an even grander journey. The Sun, the planets, the moons, and all the rest. We are passengers on a massive starship hurtling through the Milky Way. The Milky Way is an enormous pinwheel of hundreds of billions of stars. Our Sun is just one of them. Planets are gravitationally bound to the Sun. The Sun is bound to the supermassive black hole Sagittarius A star. Our Sun and its planetary system are orbiting the galactic center. That orbit is almost incomprehensibly long. It takes about 230 million years to complete one trip, a galactic year. The last time we were here, dinosaurs were emerging on Earth. That perspective shrinks human history. We're moving at about 450,000 miles per hour, or 720,000 kilometers per hour. The path isn't a flat circle. The solar system also oscillates up and down, like a horse on a carousel. We're currently moving upward through the galactic plane. Over millions of years, gravity will pull us back down. Those crossings take us through the densest parts of the disk: gas, dust, and stars. Some scientists think those passages can disturb the Oort cloud of comets. Remember, planets orbit the Sun, and the Sun orbits the galactic center, a multi-layered motion. The Milky Way itself moves through space. It's drawn toward nearby galaxies in our local group, which move toward even larger cosmic structures. Our journey is endless on scales that challenge imagination. Every star in the night sky is on its own similar journey, a fellow traveler in this vast cosmic ocean. They had humble beginnings in a vast, swirling cloud of gas and dust that surrounded our young sun billions of years ago. This cloud, known as a protoplanetary disk, was the raw material from which everything in our solar system, apart from the sun itself, was built. The story of planet formation is a story of gravity and accretion, a process where tiny particles gradually came together to form larger and larger objects over millions of years. It began with microscopic dust grains, bits of rock and ice, colliding and sticking together through electrostatic forces, much like dust bunnies forming under a bed. As these clumps grew from dust grains into pebbles and from pebbles into larger rocks, their own gravity became more significant. They began to attract other nearby particles, accelerating their growth. This process, called accretion, led to the formation of kilometer-sized objects known as planetesimals. The protoplanetary disk was a chaotic and crowded place, with countless planetesimals colliding, merging, or shattering each other. The largest of these bodies, those that survived the cosmic demolition derby, continued to grow, their gravitational influence sweeping up material in their orbital path. These dominant objects became the planetary embryos, or protoplanets. The final stage of planet formation saw these protoplanets, now hundreds or thousands of kilometers in diameter, clearing out their orbits. Through a series of giant impacts and gravitational nudges, they either consumed the remaining debris or flung it out of the system. In the inner, hotter part of the disk, rocky protoplanets formed what would become Mercury, Venus, Earth, and Mars. In the outer, colder regions beyond the frost line, massive cores of rock and ice were able to attract and hold on to vast amounts of hydrogen and helium gas from the disk, swelling into the gas giant Jupiter and Saturn and the ice giants Uranus, Neptune. Imagine a first animation showing a vast, diffuse cloud of dust slowly collapsing under gravity, flattening into a spinning disk around a bright central star. A second animation could zoom in on this disk, showing tiny dust grains sticking together, growing into pebbles, then into rocks, and finally into large spherical protoplanets. Trusted sources like NASA and the European Space Agency provide stunning videos and supercomputer simulations that model this process, giving us a window into the violent and creative birth of our own world. These models, backed by observations of distant young star systems, confirm the beautiful story of how worlds are made from dust. Our tour of the solar system showcases a spectacular diversity of worlds, each with its own character and companions. Each planet is a sovereign kingdom, and many are attended by a court of moons. Mercury, scorched by its proximity to the sun, travels alone with no moons. Venus, its similarly sized neighbor shrouded in thick clouds, also has no moons. Our own Earth is accompanied by one large satellite, the Moon, whose gravitational tug governs our ocean tides and stabilizes our planet's wobble. Mars, the red planet, hosts two small asteroid-like moons, Phobos, Deimos, likely captured from the nearby asteroid belt. Jupiter, the king of planets, reigns over a vast system of at least 95 moons, Io, Europa, Ganymede, Callisto. Saturn is equally impressive, famous for its magnificent rings and its own large retinue of moons. Its largest moon, Titan, is a world unique in the solar system, boasting a thick nitrogen atmosphere and lakes of liquid methane. Uranus, the tilted giant, has a family of large moons named after literary characters, Titania, Oberon. And distant Neptune is orbited by Triton, a strange and cold moon that orbits backward, suggesting it was a captured object from the Kuiper Belt. The speed of each planet's orbit is a direct consequence of its distance from the Sun, a law of physics first described by Johannes Kepler. Mercury races along in its path, while Neptune drifts slowly through the cosmic dark. The rotation speeds are just as varied, with fast-spinning Jupiter bulging at its equator and slow-spinning Venus remaining almost perfectly spherical. NASA's incredible repository of images and videos, from the Hubble Space Telescope to probes like Cassini and Juno, provide the undeniable evidence, showing us the storms on Jupiter, the rings of Saturn, and the icy surfaces of distant moons.